Hello and welcome to the Alternate Physics. Today we are going to talk about the alternate Newton's second law or the jerk mechanics. Now, imagine there is an alternate reality where Newton's second law is given by not F equal to ma but this equation. Force is equal to mass into jerk. You might be thinking like, what is a jerk? In mechanical engineering, jerk is defined as rate of change of acceleration, just like acceleration is defined as rate of change of velocity, and velocity is defined as rate of change of position. Now in our reality, this reality that we are imagining, Newton's second law is given by this equation, F equal to mj, and this changes everything. Let's find out. Okay, so we can actually derive Newton's first law for this jerk mechanics world. So this means there is no external force. In the absence of any external force, our equation becomes like this. F equal to 0, mj is equal to 0. Because mass is not 0, that means j is equal to 0. That means rate of change of acceleration is 0, or acceleration is constant. So this means either acceleration will have some non-zero value, let's say 2 or something, or acceleration will be 0. If acceleration is 0, then we can have another two conditions. It means velocity is constant. So either velocity can be 0 or velocity can be having some non-zero value. So in the absence of any external force, we have three situations. This situation corresponds to the condition where an object at rest is going to stay at rest forever. This is the first condition. This is the second condition. Oh, sorry, I should have said this is constant. Yeah. If the velocity is constant, then it's going to move with the same velocity forever without any external force, if there is no external force. So this corresponds to the second condition. We have another condition where acceleration is constant. So this means if an object has an initial acceleration and there you are not applying any force, this is going to continue forever. It's going to accelerate forever. This means velocity is going to increase forever. Isn't this crazy? Okay, so we can actually find out the trajectory of any object in this jerk world. First of all, you need to understand that the projectile motion in our normal Newtonian world looks like a very smooth, parabolic curve. But will it be true in this jerk world? Let's try to find out. Let's try to derive the equations. So this is the setup that I have. As you can see, I have an object which is denoted in red in color at origin, and it is given an initial velocity whose components are vx and vy. And I want to find out the trajectory, the path that this particle is going to follow. So basically what I want to find out, at time t, this particle is going to be at this xy coordinate, and I just want to find an equation of x and y in terms of t. One thing I can tell you that this object is going to have constant velocity in x direction. So this vx, this component is not going to change because there's no component of force in x direction. So this first equation, x is equal to vxt, is going to be true. Then what we can do for y component, what we can start from calculating the acceleration it's going to have at particular time moment, because in this world the value of jerk is negative and it's in the downward direction. It's a constant jerk value. We can say jerk due to gravity not acceleration due to gravity. So we can find out the value of ay, then integrating 2 times we come to velocity, and finally we come to the y coordinate. And we can combine these 2 equations and eventually we can form this equation. Okay, so as you can see, this final equation that we got for the trajectory of this particle in this jerk world looks like a cubic equation. So it means this particle is going to follow a curve like this. It's going to look like something like this. It's going to gain its initial velocity, it's going to go very far, then suddenly as it's keeps getting more and more acceleration in the negative y direction, it's going to curve more, and eventually it's going to become straight. This is in contrast with our view of our Newtonian world, because in Newtonian world, our current world, the world that we live in, when you throw a particle, it follows a very much perfect looking, absolutely perfect looking parabolic curve. So to really test this, my equation, whether it's true or not, I actually made a simulation. I made a computer program using Python to simulate this. And let's take a look at this simulation. So here is the program that I wrote that simulates projectile motion in jerk mechanics world. So I have two objects basically. One object is denoted by this picture of Newton himself. So this object follows Newtonian mechanics. So as you can see, the trajectory is just like the way we see in our world. It's perfectly symmetrical and it's parabolic. But the red one, that's the trajectory a particle will follow if it follows jerk mechanics. Okay, I actually took this simulation from projectile motion and I implemented 2D circular motion for jerk mechanics. Like I have this black dot here represents a very massive object that creates a gravitational field in this space, okay? And the gravity will be same for both of these objects, Newtonian and jerk world. And they will be given an initial velocity with some value, and the angle will be 90 degree with respect to x-axis. So if I start this simulation, both objects are thrown actually into this strong, massive object, and eventually they get sucked up inside this object. But I can change this angle from 90. I can change this angle to 75 and rerun the simulation. Let's see what happens. So with angle of 75, what really happens is this Newtonian object eventually curves and falls. But surprisingly, this jerk object, it just escapes the gravitational field entirely. Amazing. What happens if I give initial velocity as 0? I mean, totally perpendicular to the object. So as you can see, this Newtonian object seemed to follow this circular motion, but again, this jerk object just totally escaped it. And finally, I'm going to try minus 75. Okay. My objective here is to escape the gravitational field. Well, you can see a Newtonian object eventually falls into the object, but again, this jerk object, it just escapes it, man. I mean, that's crazy, right? Finally, minus 90, opposite to the massive object. So with perfectly, opposite direction, this is expected. They eventually try to go out, but they fall, their velocity reduces and they fall into it. So Newton's second law may be a very simple law, but don't go with the simplicity. It controls everything that we see in our reality, everyday world. So if a slight modification in Newton's second law will change everything, literally everything. So that the life that you see around you, I mean, so much of complications, but it's so beautiful to think about that. Everything is controlled by one simple law of physics. And as always, thank you for watching.